We'll get started here. So thanks for hiking over a couple of football fields to about as far away as possible to the main pavilion. Hopefully you're in the right talk, which is the ASP.NET 4 core runtime area for web developers. I'm Steph, and I'm one of the folks who works on the team specifically in sort of everything that's not UI related inside of ASP.NET. And what I'm going to talk to you folks here about today are sort of four specific areas within ASP.NET that we made some targeted investments in that are related to both the areas of performance and extensibility. And hopefully, as you'll see throughout the talk, there's also a certain interplay between those two. Some of the things I'll be showing you today are specifically performance enhancements in the product, so they're pretty straightforward to understand. But also, given how long the runtime area has been around, in a lot of cases, not just performance, but also security, we've sort of shifted our focus to trying to build more extensibility points into the product so that both ourselves and you folks as developers have ways to plug in additional code and functionality to sort of extend a number of our features. So the four things I'm going to touch on today that have come along in ASP.NET 4, the first one is some new resource monitoring options we have, specifically to make life easier for those of you who are trying to pack a lot of applications onto a single running server. I'm going to talk about some targeted changes we made in session state, which is one of those old stalwart features that I still see a lot of customers using, and some of the things we did in ASP.NET 4 to make it a little bit better. I'm going to talk about the output caching feature. So there's an extensibility point that was actually back in beta 1. I'll walk through it again, also in a little bit more detail about what we have today and what's planned for the future. And then I'll round out the talk explaining some of the things we've done to improve the perceived performance of starting up a cold ASP.NET application. So for the first area of resource monitoring and management, obviously most of you do some level of server-side development. It may not exclusively be on web servers, but the usual constraints, of course, are CPU, memory, and disk. And in the area of web applications, though, typically disk performance is a non-issue, right? So typically, the two constrained resources that you have to worry about are CPU and memory. And again, certainly from sort of the support cases we see in talking to customers, more often than not, it's memory that turns out to be the constraint, especially given the kinds of CPUs that are out there today. Now, historically, there's been a little bit of an issue in the sense that even though you can pack multiple ASP.NET applications into a single worker process, and that's great from a scalability standpoint, from a sort of performance monitoring standpoint, you don't necessarily know what's going on when one of those applications sort of goes rogue on you. So if you've got 10 or 15 apps sitting inside of a single worker process, and one of them starts devouring all the CPU time, today it's a bit of a detective manhunt to try to figure out, well, what's actually the misbehaving application amongst all the applications that I have running inside of a single worker process. So things have gotten quite a bit better in the version 4 of the framework. So what happened is there are sort of two pieces to the puzzle. First off, the folks in the CLR, they worked some of their magic and introduced a new feature called Application Domain Resource Management. And also, joking aside, we always have to TLA everything. So the TLA is, of course, ARM. So this ARM feature, what it does is the CLR has the ability to sort of peek into what's going on inside of an application domain, and it can actually attribute both CPU time and managed memory usage to a specific application. And what that allows us to do is to figure out with some degree of granularity, when there are multiple app domains running in a single worker process, we can figure out who's using up a lot of CPU time and who's using up a lot of managed memory. And so what we did to integrate with the CLR ARM feature is we exposed two new performance counters. And as you can see, I've got the names up there. They're pretty straightforward. One keeps track of the estimation of how much CPU time is being used up by an app, and the other one, how much managed memory is being used up by an app. So with that said, what I'll do is switch us over to my little demo laptop and actually show you some of these in action. So I've got the beta 2 build, the framework in VS running, and just to sort of simulate a misbehaving application, I did two things. First off, I created a page, real simple, runs 10,000 loops every time I hit it, and it's going to go out and use the AES encryption algorithm. So if I go out and hit this page, it's going to do 10,000 AES crypto operations. My laptop isn't particularly powerful, so that'll actually take a few seconds to chug on through. And hopefully what we'll see in a few minutes is that that will sort of show up like a red flare in the middle of the night using some of these new perf counters. And then the other thing, just to sort of set the stage, is I've got a page that's a little bit misbehaving. It has a static variable, when I probably should have used an instance variable. And each time I run it, I'm just shoving in 20,000 Unicode characters. So on any given hit, it's not actually going to use up a whole lot of memory, but I do have a little HTTP load test tool, and when we let it chug along for a few seconds, it's going to start using up more and more memory. So that's just sort of to set the stage of what I'm going to be doing wrong in this application. So let's think about it from the point of view of you're a developer, or you have to worry about administering a server. How do you actually make use of the new perf counters? So there is one small caveat, which is there's a little bit of overhead when using these perf counters. So by default, out of the box in the 4.0 framework, we don't actually have the feature explicitly turned on. So there are a couple of different ways to be able to turn the feature on. For us in ASP.NET, we try to make it simpler for all of you. And what you can do is you can go to the installation directory for ASP.NET and pull up a somewhat little-known file called ASP.NET config. Some of you have probably seen it before. It's not actually your standard web config file. It's not something that an application developer would go out and muck with, but it does have a lot of low-level configuration settings specific to how ASP.NET and the CLR interact. So what the CLR added that's new in .NET Framework 4 is within their runtime element, they now have the ability to, through configuration, turn on the application domain resource monitoring feature. So in my case, let's go out and explicitly turn it on. And then what I'm going to do is flip over to IIS. And I happen to have all the demos today running inside of the default 4.0 app pool. So I'm going to stop the application pool, give it a few seconds, and then we'll start it up again. Now, the quick reason why I have to bounce the app pool, like I was saying earlier, it's not, the ASP.NET config file, it's sort of low level. It's not monitored in the same way web config is. So if you actually want the changes in ASP.NET config to take effect, you need to make sure to cycle the worker process so that any of the settings changes actually get picked up. So at this point, we've got app domain resource monitoring turned on. We have the application pool up and running. The last thing I'm going to do is I'm going to start up a baseline app so that there's nothing to it. This is just a 4.0 app that I can ensure is running in the same worker process. And then I'll also start up my little PDC demo app. So at this point, from the perf monitoring infrastructure standpoint, we should actually have both applications available and visible inside of perfmon. So let's go out, and for the first walkthrough, let's take a look at the CPU monitoring. So I'm going to scroll up here to this perf category, ASP.NET Applications. And just due to the naming convention of the two new perf counters, in this case, the estimate of CPU utilization happens to sort out at the top. And you can see that when I look at the instances that are available that I can monitor, sure enough, I can look at the CPU utilization for my baseline app, and I can look at it for my misbehaving app. So let's add both of those to perfmon. And then, again, just to sort of make things more obvious, I'm going to tweak the scale of the perf counter so we can actually see what's going on. So right now, you can see here at the bottom, I'm monitoring both of my app domains, and I also have the operating system level % processor time counter. So let's first go to that misbehaving page that uses a lot of CPU time and let it run. If you can see, I actually have Task Manager running there in my taskbar. So it's chugging along, seems to be taking up a fair amount of time. And if I go out and snap the perfmon at this point, so I'll pause it, see a couple of things. The highlighted blips that you're seeing, that's the OS level perf counter. And now if I scroll through and I highlight my test runtime app, you'll see it also is showing that it's using up a lot of CPU time. But if I highlight my baseline app, I mean, you can barely see it. It's that little flat line at the very bottom of the perf monitor tool. So in a nutshell, that's in essence the value of being able to use app domain resource monitoring to see very clearly what specific app, or in many cases applications, are responsible for using up a lot of CPU time. A couple of other quick notes. You probably can see it there. You can see that the OS counter spikes first, and then there seems to be a little bit of a lag before the application domain counter spikes. The reason for that is, again, there's a certain amount of overhead to running all of the ARM stuff, and so what we do is we sample the CLR once every 5 seconds, both for CPU utilization and also for managed memory utilization. So if you're sitting there with a stopwatch, you're not actually going to see either one of these counters immediately spike up once you put load on the system. And part of the reason also we did that is we figured the real usage of these counters is in running applications. Again, it may be in a QA environment where you're troubleshooting things, or it may be in production. And what you're really looking for is the trend. You want to see over time what app or apps are actually responsible for using up all the resources. And having that slight lag at that point doesn't really matter anymore. So okay, that's CPU monitoring using app domain resource monitoring. Hopefully that's pretty simple and straightforward. What I'm going to do now is just clear out the perfmon tool. We'll start it up again. And this time around, what I want to do is show the managed memory utilization. So once again, we'll go back into our selection screen for perf counters. Once again, find that category, ASP.NET Applications. And this time around, we've got to scroll down a little bit to find the other new counter. So managed memory used, estimated. And I'll actually talk about why we sort of give that caveat that it's estimated. So once again, I can add counters for both my baseline app and my misbehaving app. So we'll go out and add those. And then in my case, I'll change the scale again a little bit, just hopefully to make things show up a little bit more clearly. So at this point, of course, I actually need to run some kind of page that misbehaves and uses up a little bit of managed memory. So first off, I'll just refresh this a few times in the browser, sort of get things to turn over. Come back to perfmon. Again, I'll pause it for a second. And you can see, sure enough, actually in this case, both my baseline app and my PDC application are showing some spike in memory utilization. Remember though, I've got different scale sets, so even though it looks like the baseline app is using lots of memory, it actually isn't. You can see it clocked out at about 0.5 meg, whereas my runtime app, if you look at the counters, is already up around 1 megabyte. So if I let this chug along, and in this case, I've got tinyget in a command window. So that's one of those little HTTP load generation utilities. It ships in the Windows SDK. So we'll let it sit there and chug along. And what you can see is, sure enough, over time, every 5 seconds, on that sample interval that we're using, you can see that the amount of managed memory keeps on ramping up and up and up and up and up. Now, part of the reason why I mentioned earlier that the counter is actually called managed memory utilization estimated is that the number that you see here sort of varies in terms of how absolutely accurate it is. And the reason for that is, again, as you sort of know, underneath the hood, there's a lot of magic that makes the managed heaps work, and there's garbage collection that's running in the background. And realistically, it isn't until what's called the Generation 2 collection comes through that we actually have very accurate estimates of the amount of managed memory that's being consumed by a single application. It would simply be way too much overhead for the CLR to be able to just randomly at any instant of time to immediately tell us, oh, you're using X amount of memory. So what happens is there's a certain amount of error and variance while you're running your application, and then Gen 2 collections usually roll through, maybe every couple of seconds or every couple of minutes. Everything converges again, you get a very precise number at that point in time, and then they're just sort of estimates in the interim. And then just to sort of show you the back end of this, I've also got another page that specifically dereferences everything in that list and forces a Gen 2 collection. And again, you can see pretty clearly a few seconds later, the memory utilization drops off the edge of a cliff. We pick it up in our counter, and you can see that once again, sort of the app's settled back to its original baseline state. So again, much like the CPU perf counter, the intent of this counter isn't, it's not that it's going to go out and replace someone who's experienced using a debugger or a kernel debugger or a profiler to really sleuth into the managed memory allocations of an individual object. But what this is very useful for, as you can see, I don't have to change any code in my app. I can just basically turn on the CLR monitoring feature and then very quickly be able to start getting some useful information through the perf monitor tool to see who's using all the CPU time and who's actually got a slow memory leak that's building up over time. Okay, so just to sort of prep for the other demos, what I'm going to do real quickly here is flip the app domain resource monitoring feature back off again. And then right before I flip back to the slides, we'll go out and recycle our app domain to pick up that change. Okay, so back to the slides. And for the next area that we did some investments in ASP.NET 4, I wanted to talk about session state. So this is one of those features where, I know with all the new work going on in MVC, some of the other things we're doing beyond MVC, you'd think that at some point like session state would have, gone away or checked out of the auditorium, as it were. And it sort of continues to surprise me and surprise us, but lots of customers make heavy use of session state, and that's true both external customers and internal. So I know, for example, like over in SharePoint and Office, there are various parts of the Office server product line that make pretty heavy usage of out-of-proc session state. And of course, the most common thing that we get, whether it's on the internal aliases or when a customer gets through to us is, hey, can you make my app go faster even though it's using out-of-proc session state? And this is one of these things where we sort of joke sometimes in the product groups that, it'd be nice if there were these various features where you press a big red button and it says make it go faster or make everything better. And I have to tell you that at least one of the things we did in session state is about as close as possible as you can get to saying press this big red button and just make stuff work faster. So what we did is we took the .NET Framework's compression support and we added support into both the SQL Server out-of-process session state provider and the out-of-proc state server provider. And now with a simple config switch, you can go out and optionally tell us, yes, I want all of my serialized session state to get compressed. And we'll transparently compress the serialized blob when we send it out over the wire to the remote store. And similarly, we will go out and transparently decompress it when we pull it back from the remote store and get it back onto the web server. And of course, what's going on there is effectively we're trading off CPU time, which again on web servers seems to typically be a resource in abundance, and we're trading that off to help you buy back some amount of network bandwidth. And what we've seen, both just sort of anecdotal testing and also certainly with some of the customers we work with on this, is anywhere from around a 33 to a 66% reduction in the overall size of the blob that's being shipped back and forth on the network. And so there have been customers who've had some pretty beefy network setups where they actually managed to saturate their back-end network with nothing but traffic from the web server to the SQL Server tier shipping around compressed session state. And hopefully this feature gives customers like that a lot more breathing room. The second thing we did in session state in ASP.NET 4 is we added a way to programmatically turn it on or off. And so again, if you played around just underneath the hood on what makes session state work, ASPX pages sort of give you the syntactical sugar, but what that syntactical sugar is really hiding are these rather awkward quote-unquote marker interfaces. And the session state module will sit there and it will look at the HTTP handler for the request and say, oh, you've got some marker interface that tells me you want session state. And it's unfortunately one of those things that, it's probably a late night idea back in 1999, but that's continued to bite all of us in the intervening years. And certainly we ran into that again with MVC, right? If you played around with MVC, if you try to use session state in it, there's sort of like, well, you can get a controller that supports session state and you can get a controller that doesn't support session state. So the whole point of this feature is instead of having to sit there and have something on the class that we inspect, instead you can just set a value in the HTTP context that says, look, I want session state, or I don't want it, or I want it to be read-only. It's a very, very simple change. It, of course, will require someone who moves up to ASP.NET 4 to take advantage of it, but we think it'll be actually immensely useful. And part of it is, when future versions of MVC beyond the current one come out, they'll be able to also pick up and use it so that they can actually get rid of that, some of the ugliness in their model today. And then the last area, and this is sort of more speculative and forward-looking, sort of if you have to use session state, and we can make it smaller, and we can help you, the developer, tell us when you actually need it, about the only thing left to do is to say, well, maybe I don't need all of it on a page. And this actually, this idea of partial session state was motivated again in part by some of the Office folks and also some of the folks from what used to be called Velocity, but is now I think called App Fabric caching, where if I have like 3 Word documents and then like an integer in session state, and all I want to do is read the integer value, like why am I serializing and deserializing all these Word documents? And yet that's just a limitation of how session state works today. So we implemented this concept of partial session state in terms of a very simple interface that if a session state provider and an HTTP handler both are sort of aware of this interface, they can basically tell each other, hey, I only need like session state keys foo and bar, please don't ship the other ones back and forth across the network. Now with that said, out of everything here we did in session state, this is just an extensibility point that's sort of sitting there dormant in ASP.NET 4 today. We don't actually have any concrete providers in ASP.NET 4 that implement it, but the general plan is once ASP.NET 4 and the framework RTMs, and then similarly when the App Fabric caching product RTMs all next year, is to then pretty quickly turn around and create an updated version of the distributed cache session state provider that actually bakes this feature in, because it meshes very nicely with it. So we'll flip back to the demo laptop and take a quick look at some of the compression and the customizability features for session state. So in this little demo app I've got, I just have like a really big text file, generated some of that, the lorem ipsum stuff that you see when you're doing HTML page mockups. I generated probably like an 80 kilobyte chunk of it that I'm going to go shove into session state. And right now, if I take a look at web config, I believe right now we've got session state mode set to SQL Server, but that's about it. So let's go out and fire up a page that makes use of that big session state blob. So yeah, sure enough, lots of session state. And if I go take a peek over in SQL Server at what's inside of my session state database, you'll see it's around 200 kilobytes or so of data that's sitting in there. And again, this is one of these things where, funnily enough, I'd look at this and be like, wow, 200 kilobytes, that's a lot. But again, certainly from folks I've talked to, I'll have people saying, yeah, so I have like 1.5 meg in session state. Do you think that's too big? And I sort of fall off the chair, and then I'm like, okay, we need to somehow slim down a little bit of that. So this is actually sort of on the low end of the range of what I've seen some larger customers shipping around in serialized session state. So coming back here, let's go to session state. And again, it's just sort of accidental. It sorts up at the top, but there's a new attribute, compression enabled. And let's just set it to true and say, yeah, I'd actually like to go compress my session state. And then just to sort of reset everything in the database, go out and delete that one row that was in there. And let's go out and refresh our page a few times. So great, it's the same big chunk of text. But this time around, if I take a look at the size of what's sitting inside of my SQL Server row, you'll see that's a substantial drop in size. So I dropped from around 200 kilobytes all the way down to 60 kilobytes. Now again, just, right, in terms of transparency, obviously the sample that I'm using, it's a bunch of pseudo-random text, so it's going to compress up quite a bit better than, for example, if you have a bunch of random objects with random data sitting in it. But it gives you a general idea that this is about as far as we could push it session state-wise in terms of saying, let's just do a tactical change with minimal impact that hopefully immediately buys you some breathing room. So hopefully something to keep in mind. If you've got apps moving up to ASP.NET 4, it's actually a pretty straightforward way to immediately buy back some breathing room on your networks. Okay, so that's compression enablement in session state. The other thing I wanted to touch on was what happens if I just want to customize whether or not I do or don't want to use session state. So again, I've got a very simple page here where I grab the session object out of the HTTP context, and then I figure out whether or not I'm going to do something with it. Now in my case, what I did is I wrote an HTTP module, very simple implementation of the HTTP module, went out and hooked the begin request event, and I'm doing that because that's early enough in the HTTP pipeline that when I indicate to ASP.NET what kind of session state I want, there's still enough time between when I set it and we pick up that change. And then the only thing that we do in the code is I say, hey, go look at the URL on the query string, and if I happen to see a variable called state and it happens to be set to true, I use this new API called setSessionStateBehavior. And as you'd expect, it's pretty straightforward. You just tell us specifically what kind of session state requirements you have. So if we take a look at the IntelliSense for it, it's pretty straightforward what you have. You can basically tell us required means read-write session state. Read-only means exactly what it says. You'll be able to read it, but we won't bother writing it. Disabled turns it off. And then the first option, default, that's just basically saying, hey, ASP.NET, I'm not going to tell you what to do. You go run your default logic, which is go look for these somewhat esoteric marker interfaces. So let's go out. I'll go out and zoom that back down. And let's set that back to required, which is what I want. So great, we've got an HTTP module that's running. It looks like it should opt me into session state when I want it. So first off, we'll just run the page with no state variable, and it's like, okay, wow, nothing shows up, which is expected. And then if I just come in here and say, yeah, set state to true, blammo. Now I have my huge chunk of session state showing up. And then similarly, right, I can go back to not using session state. That's all happening on an ASPX page that if we actually look at the top of the page, your first instinct would be like, well, whoa, you turned off session state. So that's sort of another point here is if you happen to be using web forms and you've explicitly set this setting, it doesn't really matter because if you turn around and use this new session state behavior method, that actually overrides any of the default behavior. We'll honor what you tell us instead of whatever we see hanging off of the page class. So those are the two things I wanted to touch on with session state. Again, hopefully for folks that, if you have larger complex apps and down the road you're moving them to ASP.NET 4, this will give you, between the compression and the customization of when you want to use session state, some pretty straightforward ways of immediately buying back a little bit of your performance. Okay, so the third area I wanted to touch on was output caching. Like I mentioned earlier, the specific thing we did here wasn't so much to actually change the performance characteristics of the feature, but rather what we did was engineer in an extensibility point that introduces the concept of an output cache provider. And the idea is to give you as developers the ability to customize the back-end persistence store for both control level output caching and page level output caching. And I have a quick note there on the slide. Just to be perfectly clear, when I actually say page level output caching, really what we mean is caching the HTTP response. So it doesn't really matter if it's MVC, web forms, or your own HTTP handler. You can go out and use the HTTP cache policy on a response, and you can plug in your own custom providers to do whatever storage you want. Now there are a few constraints when you start using an output cache provider. And the reason why these constraints exist is that fundamentally the idea behind the output cache provider extensibility point is that we wanted to have a way to be able to ship the output cache data outside of the process space. And the reason for that is, again, probably the single worst offender of sort of out-of-memory errors in ASP.NET apps is either object caching or output caching. Or for that matter, it might be your own custom caching. But it's the fact that certainly for 32-bit processes, there's a very real limit on about how much stuff you can shove into memory. And even in 64-bit land, I wouldn't recommend running around sticking 16 gig on a box and then using up like 14 gigabytes trying to output cache stuff. So the idea was to say, look, there's got to be some way to break outside of that barrier. And the way to do that is to build this extensibility point and let you, whatever, cache to disk, cache to a distributed cache, the cloud, whatever. However, when we made that decision, and we're thinking about you're putting data outside of the worker process, some things break down. And the obvious thing is that object references are pretty much meaningless the second you walk outside of the scope of an app domain in a worker process. And that's one of the things where even though you can store output cache data outside of the worker process, say I go out and recycle it. Like what happens if I have a bunch of references back to like a validation callback that are instance-based? Well, unfortunately, they're meaningless. I'm like, guess what? The object's gone. Poof, it went away. So hence the reason why there are a couple of constraints. We support absolute expiration on controls and pages that use custom output cache providers, but we don't support sliding expirations. And again, there it's like sliding expiration. What does a sliding expiration mean if I have like 5 web servers and they're all talking to a distributed cache? Like how the heck do I even keep that in sync? For file dependencies, that we support, but we don't support custom dependencies. And that's actually something it'll be interesting to see in the future beyond 4.0 RTM if we go out and make some changes and loosen that restriction. But for now, we try to sort of keep things simple and say, hey, if you like invalidate an ASPX page, we'll pick that up and we'll go tell an output cache provider to go evict its data. But we're not gonna like support writing a custom cache dependency and then wiring it up in this case. And then the last 2 points, so the substitution and validation callbacks. So substitution, remember that's sometimes called donut hole caching. We do support that when you're using a custom output cache provider, but you just have to give us a static delegate. And then similarly for output cache validation, you give us a static delegate. And the reason there is when an application comes back up and starts running again, we can at least read a serialized value that tells us, oh, I need to go to this type and call this method and sort of wire ourselves back up again. So that information can survive a process restart. So today what we've got specifically for this feature in the framework, we have the extensibility point. We now do have both it used to be called Velocity, now called Windows App Fabric caching. So we do have a prototype of that. We also have a prototype of a disk-based provider. And again, the plan is since we've got the extensibility point in the 4.0 product, that gives us the freedom next year when we have some more breathing room to actually build out the providers, probably pop them up on CodePlex initially, and then eventually sort of move them up to production grade. So with that said, let's actually switch back again to the demo laptop, and I'll walk you through the Velocity prototype that we've got right now. So let's switch over to the output caching sample, pull that up. This is actually a slightly tweaked up dynamic data project, and for the most part, it's, I left all the templates alone, but I made some minor modifications that allow me to be a little bit more restful in terms of how I page through individual pages in a database. So I use the URL routing and dynamic data and introduce the idea of, great, I can go stick the page number of data that I want on the URL. And the only reason for that is it just makes the output caching a little bit simpler to be able to say, fine, here's URL for page 1, page 2, page 3. It all has a nice straightforward mapping. Now, in terms of actually enabling output caching with custom providers, the first thing we should do is take a look at web config. So we've got an output cache section here, and that's actually been around since ASP.NET 2.0. And what we did is we added on the concept of a default provider, and we also added in a collection where I can add one or more custom providers. So again, for those of you who've ever used any of our provider-based features, this is all pretty much meat and potatoes, should be pretty familiar to you. One little side note is that for the default provider, even though it looks like we're naming a specific provider type, it turns out that this string, it's sort of a little bit of a hack job underneath the hood. It's actually a flag to us. So internally, when we refactored how output caching works, we didn't actually take like the default in-memory output caching and suddenly factor it out into its own little standalone type. Because remember, some of those constraints I mentioned earlier, like if we did that, we'd suddenly lose those abilities like custom cache dependencies. So instead, what ends up happening is when we get a request, whether it's for a control or just for an HTTP response, we say, hey, what provider should I be reading and writing from? And if it happens to be set to this string name, that's actually just a flag to us that says, oh, go take a left turn and just do the old thing that you've always done. Now, if it's not set, of course, to ASP.NET internal provider, you can see pretty obviously, I've got one name that points to the custom disk provider and one that points to the App Fabric caching provider. So that's sort of step one. Go tell us in config what are one or more custom output cache providers that you want to use. Step two, of course, is from a code perspective, let us know that if you're running a page or a control that you want to go use output caching. Now, in this case, it pulled up a page, and that's actually what the demo is going to be showing, but it turns out that if you're using a control and you want to do output caching, we have this handy dandy provider name attribute that you can use. So it's intuitive, it's what you'd expect, right? I already said a bunch of other stuff on the output cache directive, go tell me what provider I want to use. But the reason why I'm getting squiggled here is that for pages, you don't have that option. And I know it's something that, folks who've seen this before, that's one of their first requests, like, well, why can't you just let me go set an attribute on the output cache directive and I'll go tell you what provider to use. And again, this is just one of these chicken and egg problems. The output cache module actually, that's right, the HTTP module that's doing all the magic of both storing output cached responses as well as retrieving them and serving them back out. So when it's actually doing the work to say, should I serve out output cache data, that actually happens quite a few phases in the pipeline before the page ever even exists. So literally we're in this quandary that the output cache module wants to say, at least in the case of a page, what provider should I use? But there's not actually any page class instantiated in memory. So there's nothing for us to go after, there's nothing for us to reflect on or call some super secret API. So how the heck do I actually pick a custom provider if I want to do full page caching? Well, what we did is we added a new method, a virtual method, to the HTTP application class. So you can go into global ASAX, you can go write a class in a class library, either approach works. What you do is you override it, and that's where you have to pop in your own logic to say, what output cache provider do I want to use? So I apologize, I know it's a little bit awkward, it's not as slick as the declarative syntax, but that's sort of the background on like, why do I actually have to write code in this case to tell us what provider to use? Now in this case, for the demo, I'm doing something very basic. I'm just saying, hey, in this dynamic data app, if you're listing out data from a table, or it happens if you drill into the details of a row, I'm going to go out and give you the name of one of those providers in web config. And then at that point, the output cache module goes, aha, okay, I know who to actually instantiate and go read and write from. So okay, we've got web config set up with the providers. We've gone out and made the tweak in global ASAX to actually use the provider. Before we actually start using it, real quickly, this is just happens to be the PowerShell console for the App Fabric caching product. If I take a quick look, great, it's up and running, and you can see all zeros, so it's empty right now. So let's actually go out and try to make use of our output caching. So we want to run, we don't want runtime PDC, we want the output caching feature, and let's start out and go to page 1 of the products table. So again, it'll take a little bit of a while to chug through my database, but great, that popped up. Let's go out and pull up page 2, and then let's pull up page 3. And one thing you might notice is up here at the top, I happen to be spitting out 2 different timestamps. The one at the top tells us when the cached response was actually generated. The one at the bottom actually happens to be using donut hole caching to tell us when I actually requested the page. So to give you an idea here, let's hit refresh on page 3, and you'll see sure enough, even though I requested the page right here at 42 seconds past 3:38, the actual data I'm seeing was generated 20 seconds ago. And sure enough, if I go backwards to page 2, you can see the 2 time markers are different. So it looks like we're output caching everything successfully into the velocity product. Okay, yes, haha, I was running tinyget in the background, which we probably didn't want to do. But let's go back to our console here for PowerShell. And sure enough, you can see if you look at the hit counts there, it looks like we've got 3 pieces of data sitting in the cache now, which is expected, right? We have pages 1, 2, and 3. And you can also see that we had quite a few misses up front, and then we actually finally started getting hits rolling through. Now the reason why also you're not going to necessarily see a one-to-one relationship between the number of requests and what's flowing through to the provider is that underneath the hood, and again, we don't have time to go into it in detail, but underneath the hood, an output cache provider actually stores 2 pieces of information about every single control and every single HTTP response. It stores a bunch of metadata that's basically internal opaque information to you, the developer, but that's very important to us. And it stores a second piece of information, which is the actual like HTML of either the control or the response. So okay, that seems to be running. What I did want to do real quick, just to give you a flavor of what it looks like if you're a provider developer, or if you're just curious about what's floating around, is we'll drop in here to the custom provider. So let's see, we'll pull up the actual base provider, and you can see it implements the new output cache provider type. There's actually not a whole heck of a lot on the output cache provider class. There's basically an add, a get, a remove, and a set method. So you have a whopping total of 4 methods. So from a public API perspective, there's not actually a whole heck of a lot to write. The thing that's actually pretty nice about, again, what was formerly called velocity is because it actually, like, it natively has key value pairs, everything lines up pretty neatly. So, you know, if I take a look at like the remove method, you can see that from the point of view of what I need to do with the quote unquote storage engine, like there's nothing I need to do. I take a key, I go to velocity and I say, go eject it. Or similarly, if I'm calling set, it's like 1 line of code for me to go jam something into the cache. That's one of the reasons why we actually love that product is from an API perspective, it's very simple for us to wire up to it. So what I'm gonna do here is fire it up in the debugger, and we'll pull up one of those pages from that table. And what should end up happening, assuming I haven't talked here too long, perfect. So we dropped into the retrieve entry method. You can see here we're returning back a piece of data to ASP.NET. And if we take a look at what it is, this is actually, in essence, the programming contract between a custom output cache provider and the internals of the ASP.NET output caching feature. So what happens both when we talk to your provider and when the provider gives us data back, everything is in terms of these output cache entries. If you drill into it a bit, it makes sense. We basically chop, in this case it's a full page that we're caching, so we chop that up into 2 chunks. There's the headers and there's the entity body. So headers should be pretty obvious, right? Some very familiar stuff, content type, our ASP.NET version header, pretty simple stuff. And then in this case, the velocity provider that we've got is returning back a bunch of memory buffers, and also in this case, this thing called a substitution response element. So we basically have a programmatic representation of chunks of memory that represent the actual output cache response. And then we also have a representation of a donut hole caching static delegate. We have a similar one for the validation callback. And then you won't see it here today, but there's also another element type called file response element. And the file response element is actually pretty cool. It turns out that if you're output caching a response and you don't have something complicated like this donut caching sitting in the middle of it, you can actually have ASP.NET give a bunch of memory buffers to your provider, but your provider can turn around later on and just give you back a file handle. Because all we care about is that you give us back the data in some fashion that corresponds to what we originally gave you. You don't actually have to give it back to us as the same types. So you can take a bunch of chained memory buffers, coalesce them, dump them on disk, and a subsequent response, you just tell us, hey, ASP.NET, here's this file and offset into it. You go transmit it. And then we'll use the vector send APIs and IIS to just slurp that thing right off disk and send it up the network pipe. So it's a very, very high-speed way of doing output caching. Okay. So I think that's enough on the quickie overview of output caching. We'll flip back to our last topic in the slides, which is amortizing startup costs for applications. So this scenario is a little bit different. It's not about going out and taking a specific ASP.NET feature and making it run faster. It's about trying to make a very specific point in time in your application appear to run faster to your customer. And so the idea here is that, A, we know that a lot of you have complex apps that take a while, and sometimes a while from what I've seen can be on the order of minutes, to bring an app to a state where it can actually start serving pages. And obviously, if you have the misfortune of being the very first customer to make a request into that app, you're going to be waiting a while. And then we also know that folks have apps where once they're actually up and running, there are specific pages in those applications that can be pretty heavyweight. And so again, when the customer happens to stumble on to that kind of page, it takes them a while they wait for the data to come back. So there's some technologies that IIS introduced, and they specifically introduced it in IIS 7.5. So that's the version of IIS that's available in Windows 7 Client and also in the server product, which is Windows Server 2008 R2, which is getting to be way too many syllables for our products. But they built in a specific low-level technology called Service Auto Start. And it's basically a way to tell IIS two important things. You can tell IIS, hey, I want a specific worker process to always be up and running. So if my machine reboots, if I do a scheduled recycle of a worker process, you name it, it will ensure the fact that A, one or more worker processes come back up, and B, it will actually look into individual applications that are mapped to that worker process, and it can basically call into them and say, hey, application, even though I don't have a pending HTTP request for you, please start yourself up. And then what we did in ASP.NET 4 is we basically glued onto that so that managed developers have a coding entry point that will be triggered when IIS 7.5 does this. Now there's probably going to be a little bit of confusion though on, hey, if you're a web developer, should I actually use what I just talked about, or is there something simpler? And for those of you who maybe poked around a bit up on the ASP.NET site and looked at our white paper on like a bunch of stuff of what's new in ASP.NET 4, for a few months there we had talked about the Service Auto Start functionality. Well, it turns out the IIS folks did us one better, and a few weeks ago, specifically aimed at HTTP-only applications, they introduced a feature called Application Warmup. It's built on top of the same auto start functionality in IIS 7.5 that we built on top of, but it works specifically with HTTP apps. And the nice thing is, from the point of view of us as ASP.NET developers, I don't have to change any of my code. So if I have a bunch of code sitting in the application start event in global ASAX, guess what? It runs. If I have a bunch of special warm-up URLs, or heck, I just have whatever, like please go run the front product catalog pages for my 20 top products, guess what? It can integrate with it. Like I don't have to go out and learn anything new to code against. And that's one major advantage of it. The other thing that's really cool is as long as you're on IIS 7.5, you can take advantage of this new application warm-up module. So you don't actually need ASP.NET 4 to make use of it. You have an existing ASP.NET 2.0 app, go pop it on WS08R2, install this module, wire it up, you're good to go. The point where we did glue together ASP.NET 4 and IIS, what that really comes down to is that's auto start integration for the non-HTTP world. That's basically why I'm telling you that here today, and it's what we'll tell customers going forward. So folks who live, for example, in a WCF world, where you have TCP/IP activated web services, or you're activating a workflow instance over named pipes. Basically, what we did in ASP.NET 4 and what IIS 7.5 did is we gave those developers the equivalent of the application start event in global ASAX. So with that said, let's flip back to the laptop. I'm going to continue to use this output caching project. But this time around, real quick, I'm going to roll us over to use the disk cache. So basically, I want to use this disk cache provider. So I'll make a slight tweak to global ASAX. So it picks up and uses the disk cache instead of the distributed cache. So that's the only change I'm going to make for the demo in my application code. Now the way this disk cache provider works is you can see here I'm in the www root output caching folder, and then I have a subfolder called disk cache. And this little provider can go out and read and write stuff to it. It basically reads and writes serialized output cache data to this directory. Now to configure IIS 7.5, because here I'm running on the Win 7 client OS, you can see I've already installed the warm-up module on my, on my laptop. So we'll just pull it up. So right now I don't have anything set. There are basically two levels of settings that you make use of in this application. One is just sort of the global stuff. You know, yeah, I want to use application warm-up on my server, please go turn it on. And yeah, by the way, please make sure the application pool I'm living in will actually be guaranteed to always be up and running. So the interesting part is, what do I actually tell it to do? Well, what you do is you give it one or more relative URLs that this module is going to run. And in fact, in earlier incarnations of this, we actually called it the HTTP request faker, because literally what it's doing underneath the hood is, if you just booted up your machine, this module fires up, says, fine, go start these worker processes, go peer into the apps for which this has been configured, and start shooting HTTP requests into the app. Like I said earlier, that's really nice from a developer standpoint, because there's not like some weird new programming model that I got to go grok to go like wire up. It's like, whatever, I got my app, I have URLs, I have global ASAX. It's like a human being is making HTTP requests, but instead it's this module doing it. And then there are a couple of optional things. You go tell IS, hey, what status code do I expect to get back? If there's a mismatch in the status code, it'll go report an error into the application log. I don't have anything for this demo to put into this request context parameter, but it's just basically a string that IS will pipe through to ASP.NET, and you can actually pull it back out of the server variables collection. So there's some kind of customization info you want to read at startup time, you can pop it in here and you can actually read it at runtime. And then for the send mode, you can tell the module how it should actually be firing off those URLs. So if you mark some of the URLs as synchronous, it's just going to start with the first one, wait for it to complete, call the next one, the next one, the next one. So it just works top to bottom. And then for asynchronous, what happens is IIS, just like ASP.NET, has a thread pool, and it'll just use as many threads as it can spin up, and it'll ask for all of the URLs in parallel. So I've actually got a few of these already sort of pre-canned off to the side. Just going to copy them and drop them into the web config for my application. So I'm going to come down here to the system web server section. Again, might not be familiar for folks who are still on the older IIS versions, but this is the equivalent of system.web, but for IIS. And you can see I just dropped in and said, hey, IIS, I want you to warm up this app, and I got 3 URLs I want you to run at warm-up time. So with all those changes set, let's come to my app pool. Let's stop it, and then I'm going to restart it so that the changes actually take effect. So we'll start it up. You can see down here off to the side, looks like my machine's actually doing something, so I'm going to bet that it's probably making all the requests. And if I come over here to my disk cache directory, you'll see automatically, poof, I've actually got pages 1, 2, and 3 out of that products table. And like I said earlier, this is basically the serialized representation of an output cache page. So there's a bunch of metadata goop up at the top, and you can see pretty quickly, that certainly looks like the HTML of my page. If I scroll down a bit, sure enough, that's the raw metadata and HTML for my page automatically generated without even making a single request into my application. And like I said earlier, to reiterate, just as long as you're running on either Win7 client or Win7 server, that module will work for you. So even though I know this talks primarily about ASP.NET 4, it's actually a pretty cool little feature that you can start using today with your existing ASP.NET apps. Okay, so just to wrap things up here, 4 major things we talked about. We talked about CPU monitoring and managed memory monitoring for application domains. So for those of you who want to pack a lot of applications into a single worker process, that should make life a little bit easier for trying to track down those misbehaved apps. I showed you how easy it was to turn on compression for our SQL Server and out-of-proc state server providers, and also the new programmatic option that lets you turn session state on and off dynamically. We talked about output caching pretty extensively. The main thing there is just sort of keep an eye on things. Like I said, next year after 4.0 RTMs and velocity RTMs, we'll be able to kick some of those providers out the door. And then lastly, we talked about the functionality that's there in IIS for amortizing the cost of your cold start applications. So that's the talk. Please don't forget to fill out your session evals. And I've got probably about 6 minutes here if any folks have any questions on this or anything else. So thank you.